The problem from GATE Physics 2017 reads as follows. The best resolution that a 7-bit A to D converter with a 5-volt full scale can achieve is dash millivolts. This is a numerical answer type question. We'll find out our answer and then round it off to 2 decimal places, and we'll try to fill in the blank here. First, let's look at what in as far as analog to digital conversion is concerned, what do we mean by resolution? So we have an analog input and we have a digital output. We know that much. On the left side you can see the input. In the red line you have minimum and the blue is the maximum. Similarly, on the right side the red is the minimum and blue is the maximum. And let's say this voltage is Vmin to Vmax, so the difference will be Vx minus Vmin between the input voltages. Similarly, the minimum output is 0. You cannot go below 0 as far as the digital input is concerned, and the maximum input, if it's a n bit convert, if it's an n bit signal, and the maximum value that you can achieve is 2 raised to the power n minus 1. This is the maximum digital, this is the maximum in the decimal value that you can achieve, right? So the difference between them again is 2 raised to the power n minus 1. Now please note that on the left, this is just a mapping that we are doing from an input to output. We are not creating anything out of the blue. So these two things should be the same. So whatever the difference between the minimum and maximum is, should be the same in both the cases, because it's just a mapping that we are doing. Now here it's important to define what do we mean by resolution. The resolution is minimum value that can be distinctly measured. This is the definition of resolution that we see in microscopy and in fact in any other field that we see. As far as digital signals is concerned, that means the difference of 1 bit. So you can see, let's say when we are in green, right, when we are here, so let's say we have some let's say some whatever is the are the MSBs. Let's say the final 2 digits are 100, right? So the immediately next value has to be dash dash 101. Just the 1 bit change, that's all we should see. And if we are distinctly able to measure that, that will be the resolution. So 1 bit change in digital side is the resolution, right? And we know now that so we have from, in order to go from minimum to output, we have to take 2 raised to the power n minus 1 steps, and we all know that 2 raised to the power n minus 1 is nothing but Vx minus Vmin, which we established earlier. A simple unitary method tells us that one step will be equal to Vx minus Vmin over 2 raised to the power n minus 1, which is nothing but the resolution, because you have defined the resolution in such a manner that 1 bit change is the resolution. So this is the corresponding value in volts that we can measure. Now we can come back to our question, and in this question we were given n equal to 7, because it's a 7-bit A to D converter, which is written here, and we also know that Vmax is 5 volts. It's written here. Vmin we don't know. If we don't know any Vmin, we'll simply assume it to be 0, and we'll put the formula for resolution now. So resolution is nothing but, we saw, Vx minus Vmin divided by 2 raised to the power n minus 1. That will be 5 minus 0 on 2 raised to the power 7 minus 1. So that will be 5 over 137. And if you try to solve this, it will come out to be 39.37 millivolts. So we'll simply put this answer over here, and it's up to 2 decimal places. So that's all we had to do, 39.37 millivolts. And this is the only key thing that you have to remember. Thank you for listening.